So we just established a procedure for finding intercepts algebraically. If you want to find an x-intercept, you need to set y equal to 0 in the equation and solve for x. And likewise, if you want to find a y-intercept, you need to set x equal to 0 in the equation and solve for y. So in example 2, we are going to practice this procedure. So let me scroll and read the directions. So here we go. Example 2. For each equation, find the intercepts algebraically. Then make a table of values to graph the equation. All right, so if you kind of flip through this example before we start, there are 4 different equations that we are going to take a look at, okay? The main goal here is to find the x and y intercepts of each equation algebraically, and then once we do that, we are going to make a table of values in order to graph the equation by hand. Okay, now that might seem odd, okay, because we are concentrating on intercepts here. So why are we going an extra step and then graphing the equation out? And here's the answer, okay? Remember I told you the first part of this section concentrates on intercepts. And then the second part of this section, we are going to study symmetry. Okay, when we get to symmetry, we are going to work the same 4 equations, and the graph is really important for symmetry. Okay, so when we find the intercepts, the x and y intercepts for each equation, those are going to be points on the graph. Okay, so by finding the intercepts, we are already getting a handful of points on each graph. So then we're going to make a table of values to get some additional points on the graph so that we can complete our graph. Okay, so that way when we get to symmetry and we work with the same 4 equations, we can just flip back to the picture when we talk about the symmetry of each equation. So that's why we're going the extra step and also graphing in addition to finding the x and y intercepts. All right, so let's start with example A here. The equation we are dealing with is y equals x squared minus 3x minus 4. Okay, again, we are going to start with finding intercepts algebraically. Okay, it does not matter if you start with the x-intercept or the y-intercept first. Doesn't matter. Okay, I typically just start with the x-intercept. Okay, all right, so for the x-intercepts, okay, I'm going to write this down. And what I do, okay, if I'm finding an x-intercept, as soon as I write that down, I write out to the side the procedure for finding an x-intercept. Okay, so remember what it is. If you want an x-intercept, you need to set y equal to 0 and then solve for x. Okay, so to find an x-intercept, I need to go to my equation and set y equal to 0. Okay, so let's do that. Okay, so here is our equation. Okay, and everywhere we see a y, we are going to set it equal to 0. Okay, so we have y equals, so instead of y equals, we're going to have 0 equals. And then the right side of the equation just has x's. Okay, so this is what we're going to get if we set y equal to 0. We're going to end up with 0 equals x squared minus 3x minus 4. Okay, we need to solve this for x. Okay, now, yes, you're in college algebra, but there are some prerequisites that you are required to know going into this class, and one of them is working with quadratic equations. Okay, remember an equation is a statement with an equal sign. That's what we have here, and in particular, it is quadratic. Okay, so I'm going to go up to the top here and write this down because you're going to see quadratic equations throughout this class. So from the get-go, I want you to be reminded of what a quadratic equation is, okay? When you look at it, the highest power of x is the second power, okay? So a quadratic equation has the format y equals a number times x squared plus or minus another number times x plus or minus another number, okay? So x is your variable here, or y is as well. So x and y are the variables. A, b, and c are just numbers. Okay, so that is what a quadratic equation is. Okay, and what we're doing here is, so since we're solving for x, we have to solve this quadratic equation. We have to find the value or values of x that make this a true statement. Okay, there are a couple of ways to solve a quadratic equation, so let me write that up here. Again, this is something you will see throughout this course, so make sure we're starting off learning this from the get-go, or refreshing our memory from the get-go. To solve a quadratic equation, two of the things that you can try are, one, you can try factoring, and then the other thing you can try is the quadratic formula. Okay, so either of those should work. Okay, factoring is also a prerequisite for this class. Okay, if you struggle with factoring, there is a review on D2L under prerequisites that you can go to try to go through the different methods of factoring. Okay, to be honest, we don't do a whole lot of factoring in this class, so if you don't want to spend the time going through and reviewing factoring, that's fine. You can always just try to do the factoring through trial and error. But that worksheet is out there under prerequisites in D2L. Okay, so if you want to take a look at that, it kind of goes through the different techniques of factoring. Okay, the quadratic formula. Okay, you can also use that to solve a quadratic equation. It tells you how to solve for the x values. It relies on a, b, and c. A is the number in front of x squared, b is the number in front of x, and c is just the number. It says that if you're solving for x, then the solutions are negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so you've seen that before, I'm sure. Okay, we don't really work with the quadratic formula until chapter 4. You can of course use it before chapter 4. It's just a matter of personal preference. Do you prefer factoring, or do you prefer working with the quadratic formula? If you do choose to use the quadratic formula, keep in mind that the quantity b squared minus 4ac, that entire quantity is under the square root, and then the entire numerator, negative ba plus or minus the square root of b squared minus 4ac, is divided by the 2a. Okay. All right, so we're gonna try to solve this quadratic equation down here. 0 equals x squared minus 3x minus 4. Okay, again, this is a quadratic equation because it's in the format 0 equals ax squared plus bx plus c. Okay, basically you can identify a quadratic equation because the highest power of x is the second power. Okay, I'm going to solve this one by factoring. Okay, and again, I just want to emphasize, if you're not great at factoring, either go through the prerequisite worksheet on D2L or just use trial and error. Okay, you can get away with that in this class. Okay, regardless of whether you factor or use the quadratic formula when you're solving for x, it is a requirement that one side equals 0. Okay, so we have that situation here. One side of the equation is equal to 0. If that were not the case, then we would need to move one or more terms over so that one side would be equal to 0. Okay, one side must be 0 before you factor or before you use the quadratic formula. Okay, all right, like I said, I am going to do this through factoring. Okay, so to factor, we're going to leave the 0 on the left side, and then we're going to factor the non-zero side. Okay, so basically you're taking x squared minus 3x minus 4, and you're trying to write it as something times something. Okay, so basically this first term here is x squared. So we know if we do x times x, those two things will multiply together to give us x squared. Okay, so then you're either going to have to use the factoring techniques or use trial and error to try to make the signs plus or minus work out, and the numbers, you need it to work so that if you multiply this something times something out, you end up with x squared minus 3x minus 4. Okay, so what we're going to do here, I'm going to show you the technique. The technique for this one, okay, this is a straight ax squared plus bx plus c. The number in front of x squared is 1. And if that's the case, then what you do is you need to find two numbers, and signs are important. You need two numbers that multiply to be the number, the constant. So -4, and then they need to add up to the number in front of x, which is -3. Okay, so we are in search of two numbers that multiply to be -4, the constant, and they add up to the number in front of x, which is -3. Okay, so if you think about that, two numbers that do that, and like I said, signs are important. The two numbers are going to be -3 and, oops, nope, that doesn't work. I was thinking -3, -1, but if you multiply those guys together, you get +3, not -4. Okay, so let's see here. What about, let's see, -4 and +1. Okay, those are going to be the two numbers. Okay, if you multiply them together, -4 times +1 is -4, and then if you add them together, -4 plus 1 gives you the -3. Okay, so these are the two numbers that you're looking for, and once you've identified them, then that's what you need to write in the parentheses. Okay, and it doesn't matter which order you do it. Okay, one number is going to be -4, and the other guy is going to be +1. Okay, the great thing about factoring is you can check yourself. Like I said, if you multiply this out, x minus 4 times x plus 1, you should get x squared minus 3x minus 4. Okay, now when you multiply this out, you need to FOIL this. Okay, you've got to distribute correctly. Okay, FOIL stands for, let's see here, if I did FOIL, you may or may not have seen this. FOIL stands for first multiplying the first terms, then the outer terms, and then the inner terms, and then the last terms together. That way you don't forget any piece of this. What I typically do is I do a box method, which basically does FOIL for you. I take these are called factors. These are the things that you're multiplying together. So one factor is x minus 4 and the other factor is x plus 1. So what I do is I make a box out of this. So I take the first factor and write it out. So we've got x minus 4. And then the other factor is x plus 1. Okay, and then you make a box. Okay, like this, and then you multiply each pair together. So x times x is x squared, and then x times 1 is x, -4 times x is -4x, and then -4 times +1 is -4. Okay, and then these, if you multiply these two factors out, the result is going to be what's in these boxes. Okay, so x squared plus x minus 4x minus 4. Okay, and then these guys are like terms. Okay, like terms, you have to have the same variables raised to the same powers. So both of those guys have just x to the first power, so you can combine them. Okay, x, or the x squared, you can't combine it with anything else because there's no other x squared term. But x minus 4x is going to be minus 3x, and then you've got the number by itself. Okay, so this checks out just by multiplying the factors back out. You get what you started with. So this is correctly factored. Okay, if you had multiplied it out and you didn't get what you started with, you did not factor correctly. Okay, so that's how you can check yourself. Okay, all right, so here we go. Okay, so again, we are going back to 0 equals x squared minus 3x minus 4 because we are trying to find the x-intercepts here. We factored the non-zero side into x minus 4 times x plus 1. And so now what we're going to do is we're going to take each factor and set it equal to 0 and solve. So we're going to get x minus 4 equals 0, and then x plus 1 equals 0. Okay, and then if you solve this, add 4 to both sides, you're going to get x equals 4, and then subtract 1 from both sides, you're going to get x equals -1. Those are your two x-intercepts. Okay, so the x-intercepts here, okay, I'm going to write them as an ordered pair. Okay, so the first x-intercept here is going to be x equals +4. That's the x value, and then the y value, remember, is 0. and the other x-intercept is going to be -1, okay, and the y value is 0, okay. So those are the x-intercepts, okay. Remember, we are going to be making a graph of this equation, okay. We can already plot these 2 points on the graph, okay. If you look at your x-axis, we know the graph of this equation is going to go through -4, 0, and, oops, sorry, I meant to say +4, 0, so let me erase that and fix it. So +4, 0, and then -1, 0, okay. That's where your graph is going to cross or touch the x-axis, okay. All right, so now what I need to do is shift gears and do the y-intercepts. Okay, so if you scroll back up and you look at the procedure for finding a y-intercept, now you're going to take your original equation, you're going to set x equal to 0 in the equation and solve for y. Okay, so very similar. All right, so coming back down here, we are going to set x equal to 0. Okay, so going back to the original equation, which is highlighted in yellow, everywhere you see x, you're going to replace it with 0. Okay, so we're going to get y equals 0 squared minus 3 times 0 minus 4. Okay, and we're going to solve this for y. Okay, so this is going to give us y equals 0 squared is 0 minus 3 times 0, that's also 0. So this is going to leave us with -4. Okay, so finding the y-intercept here is much easier than finding the x-intercepts. Okay. All right, so we need to write this as an ordered pair. Okay, so remember, x goes first, the x value is 0, and then the y value is -4. Okay, all right, so there you go. So this is going to be another point on the graph. Okay, so I'm going to go ahead and plot it. So this is the point 0, -4. Okay, your graph is going to cross the y-axis at -4. Okay, all right, so we have found the X and Y intercepts. Okay, that was the main goal of this question. We need to complete the graph of this equation. Okay, we have 3 points on the graph so far, the 2 x-intercepts and the 1 y-intercept. But again, you know, how do you connect the dots? What does a complete picture of this graph look like? So what I suggested in the directions is to make a table of values to graph the equation. Okay, so let me show you what I mean by that. Okay, so the equation itself that we're dealing with is y equals x squared minus 3x minus 4. Okay, to graph something by hand, you can make a table of values. You are in charge of picking x values, and then what you do is you plug the x value in to get the y value, and then that gives you an ordered pair to plot. Okay, so that's what we're going to do here. Okay, so I'm going to make a table. Okay, so I'm going to go ahead and set it up here. So maybe something like this. Okay, and then I have a little vertical line here. Okay, so here we go. Yeah, something like this. Okay, nothing fancy. All right, like I said, you are in charge of the x values, and then you're going to take each x value that you pick and you're going to plug it into the equation y equals x squared minus 3x minus 4 to get the y value, and then you're going to have a point, an xy pair to plot on your graph. Okay, so that's how this is going to work. Okay, so that's our table. Okay, and I'll put a last column here. This is going to be the point that we plot. Okay, all right. Now, you can pick pretty much anything you want for x. Okay, there are exceptions for some equations, but we'll get into that later in the semester. But let's look at what we have so far. Okay, so far we have the point at x equals -1. We have the point at x equals 0, and we have the point at x equals 4. Okay, so let's try to fill in what's going on in between. Okay, so if you can see where my cursor is here, let's figure out what the y value is at 1, 2, and 3. Okay, and if you want more points, you know, you could figure out what's going on the other sides. Like you can look at -2 and you can look at +5. That's up to you. Okay, the more points you plot, the better your picture is going to look. Okay, all right, so based on what we have so far, let's take a look at what's going on at 1, 2, and 3, those x values. Okay, we're going to plug in each one to our equation. Okay, so if x is 1, we're going to get that y is equal to 1 squared minus 3 times 1 minus 4. Okay, that's going to give us 1 minus 3 minus 4. So that's going to be negative 2 minus 4. That is going to be negative 6. Okay, so that tells us that if x is 1, y is negative 6. So that is the point we need to plot. Okay, so let's go back over here. We're going to plot 1, negative 6. Okay, and then now we're going to plug in x equals 2. So if x is 2, we're going to get y equals 2 squared minus 3 times 2 minus 4. That's going to give us 4 minus 6 minus 4. Okay, that's going to give us negative 2 minus 4, which is also negative 6. Okay, so if x is 2, y is negative 6. And we will plot that point. Okay, here's where x equals 2. Here's where y is negative 6. Okay, and then we'll also plug in x equals 3. Okay, oops, wrong page. All right, so here x is 3. Let's plug that in. Okay, so y is going to be 3 squared minus 3 times 3 minus 4. That's going to be 9 minus 9 minus 4. It's going to be 0 minus 4, which is negative 4. So if x is 3, the y value is negative 4. So we're going to plot the point 3, negative 4. Okay, so that's going to be right here. Okay, so this gives us a much better idea of what the graph of this equation looks like. Okay, if we go ahead and connect the dots, we are going to get a U-shaped graph. Okay, so let me try to do this. It's hard to draw on this thing. Okay, you're going to get this U-shaped graph that looks like this. Okay, remember, we only plotted some of the x values. Okay, so you're going to get this U-shaped graph. Okay, in both directions, it's going to go up forever. Okay, notice between notice between x equals 1 and x equals 2, it's not a flat line. It's going to be curvy because you're trying to make a U shape here. Okay, but this is the graph of the equation here. Okay, when you are working with a quadratic equation, okay, you're always going to get a U-shaped graph. Okay, so I'm going to write that up here as well. The graph is a U-shaped curve, and you may have heard the name of this before. It's called a parabola. Okay, so since this is a quadratic equation that we're dealing with, the graph is a parabola, and we know specific points that this parabola goes through. Okay, so that is the end of this particular example. Okay, again, the big ideas or the big goal here was to calculate the x-intercepts. Okay, 4, 0 and negative 1, 0 algebraically, we did that. We also calculated the y-intercepts. Okay, there's only 1, 0, negative 4. Those were the goals, to get the x-intercepts and the y-intercepts. Okay, we went a step further. We used the intercepts, and then we made a table of values to get additional points so that we could plot the graph of this equation, because we are going to look at this same equation when we turn around and do symmetry later in this section, and having the graph really helps.